Hello everyone, this is Steve. Thanks for joining me. We're going to talk a little bit more about the ellipse in this video. So for our first exercise here, an ellipse is centered at the origin, like they always are in Math 121, and has a major axis that is 30 units long and a minor axis that is 12 units long. Give two possible equations for the ellipse I am describing. The reason there's two possible equations is because I don't say which direction the major and the minor axis are going. So what we could have is we could have the major axis going left to right, being 30 units long, or we could have the major axis going up and down and being 30 units long. So that's why there's two possible answers for this. But no matter which one the answer is, we can always write them as x squared over something plus y squared over something equals 1. And I can do the same thing over here. X squared, y squared equals 1, when these are both over something. So the secret to finding out the numbers that go underneath is finding the distance from the center to one of the intercepts. So for instance, with this one right here, this first one, this kind of Ernie ellipse, this short and fat one, we go 15 units left and right. 15 this way, 15 this way. Because the minor axis is 12 units long, we go 6 units up and 6 units down. So that's pretty much all we need to know to put the numbers underneath x squared and y squared. We just need to square those numbers. So since we're going left and right 15, we square the 15, which is 225, and that goes under the x squared. And underneath the y squared, we square the 6, and that's going to be 36. And that's one possible equation. But if we look at this one over here, and you might have already guessed what's going to happen here, that's okay. Up and down 15, left and right 6. So the only difference here is where the numbers go. So we left to right 6, we square 6, 36 goes under the x squared, and we square 15, and once again that's 225, and that goes under the y squared. So these are two different ellipse equations. These are not the same equations, they're two different ones because of where I put the 225 and the 36, but they both match the description of having a major axis 20 units long, a major axis 30 units long, and a minor axis that is 12 units long. All right. Next problem. An ellipse has the following characteristics. The foci are at -6, 0, and 6, 0, and the length of the major axis is 20. Now for this one, the foci are left and right, and that means the major axis is also left and right. So I'm going to draw a crude picture here of my ellipse where the foci are here, and so that's 6 units and that's 6 units. And then the vertices, which are the endpoints of the major axis, are there, and that distance is 10, and that distance is 10. I'm really just trying to write an equation for ellipse though, so I know it's going to look something like this. X squared over something plus y squared over something equals 1. So I actually know one of the numbers pretty quickly, and that is, since I'm going left and right 10 units to get to each vertex, that means this 10, because it's left and right, is the secret to the number under x squared. Since you're going left and right 10, you square that number, 100, and that goes under the x squared. And that's actually what we sometimes call a squared, the larger number. We also know that we are going left and right 6 units to get to each foci. And if we square that number, 36, that is called c squared. C corresponds to the foci. And then we know for an ellipse that we have the equation a squared minus b squared equals c squared. So we know we have 100 minus b squared equals 36. And if we solve this for b squared, which is a little bit tricky because of the minus sign, so the way I do it is I add b squared to both sides and subtract 36. We get that b is equal to 8. But we actually don't need b, we just need b squared, because the number that goes here is b squared. And that's going to be 64. So this right here is the equation that matches that description. All right, everyone. It helps to draw a little picture even if you don't draw the complete ellipse. I hope that helped. Thanks for watching.